now move on to composite functions, where one function is substituted within another. Here we have g of f of 3. We're going to begin at the innermost part of this function and find f of 3. F of 3 is 3 cubed minus 4 times 3. That's 27 minus 12, which is equal to 15. Our function now becomes g of this 15, which we're substituting in. That becomes the square root of 2 times 15, which gives us the square root of 30. Okay, now this g of f of 3 can also be written as g composite f of 3, where this open circle there is called the composite notation, g composite f, and that is equal to, as we just found, the square root of 30. Continuing on, we have h composite g of 72. This can be also written as h of g of 72. So the first thing we want to do is find that g of 72. G of 72 is equal to the square root of 2 times 72, which is equal to the square root of 144, which is equal to 12. So this whole input here is going to be 12, and now we're finding h of 12. Well, h is the function 2x plus 3, so we're going to have 2 times 12 plus 3. That's 24 plus 3, which is equal to 27. Now we're being told to find q composite p of x. There's no number to substitute in. Basically, we're taking p and substituting it into q. It's always the function closest to of x being substituted into the function further away from the of x. So this is going to equal q of p of x, which is the x squared minus 9x. That's not a very good q. Let's write it that way. Now, q of x is 1 over input minus 10. So this is going to equal 1 over input x squared minus 9x minus 10, which I'm going to now factor into 1 over x minus 10 times x plus 1, because we're interested in finding the domain of this function. Notice how x cannot equal -1 or 10. I put them in numerical order. And so our domain that we're looking for will be all other values of x, starting at -infinity up to -1, united with the interval between the numbers, united with the values to the right of 10. Write a function that represents the cost c of x for x tickets. Well, if the tickets are $60 a piece, the cost as a function of x will be 60x. There is a sales tax of 5.5% and a processing fee of $8 for the whole group of tickets. So write a function that represents the total cost t of a for $8 spent. So t of a is going to be 1.055a. That'll basically be 5.5% plus the original 100%, 105.5% of a, plus $8 being added on. For part C, though, they want t composite c of x, where c now gets substituted into t. So we're now going to have 1.055, and instead of a, we're going to have 60x substituted in from part A, plus 8. We will now distribute to get 63.3x plus 8. In part D, find this function with 6 substituted in. So t composite c of 6 will be 63.3 times 6 plus 8. And I've done this on my calculator already. This will be 387.8. And we are being asked to interpret this. That says the total cost to purchase 6 tickets is $387.80. Now we could have done this as a two-step process, multiplied the 6 tickets times the $60 each, found out that that was $360, then taxed on the tax and then tacked on the service fee. Or we could have gone straight to this composite function that did all that stuff for us.